minutes so that you guys have an idea that it's not supposed to take you 40 minutes or 70 minutes to do the same lab. I got my pH probe connected to my computer. You guys can use a Spark if you like, or the computer. It's your choice. When you guys use the computer, it's easier to export the data, but exporting it from the Spark is just as easy. So the first thing I need to do with my pH probe is what? Calibrate. That's right. So I unpacked it. I have the speaker. I'm going to label everything so I know where to find it. So I have my beaker here. I'm going to call it my waste beaker. Masking tape, big orange Sharpie. Take my distilled water bottle and I rinse it off. And then I'm going to plug my probe in. And when I plug my probe in, I'll see a pH reading at the top of my screen here. So now I have my pH probe almost ready to go. So the next thing I'm going to do is I'm going to select my pH probe. I'm going to click on Show. It gets me to the screen. I want to calibrate. Do you remember which setting I click on to calibrate? Settings, good. And I click on Calibrate Sensor. So I have a pH sensor, 2-point adjustment, click Next, and I have a pH of 4 and a pH of 10. I'm going to change my 7 to 10. And I'm going to start with my pH 4. Now with this, be sure that you are putting a pH 4 buffer into a pH 4 beaker. Do not mix them up, otherwise you'll ruin the results for everybody in the class. So I'm taking my pH 4 buffer, pouring into my pH 4 clearly labeled beaker. This pH 4 beaker, there's 1 or 2 of these for the entire class. So when you're done with it, you don't clean it, you pass it on to the next group that needs to use it. Notice I'm sealing this bottle in case I knock it over, it won't spill. I place this on my stand, I drop my probe, whoops. I drop my probe into the buffer solution. I wait a few seconds, ideally 10 to 20 seconds. Then, once I've waited long enough, I haven't, but I'm going in the interest of time, I click Read from Sensor. So then, that is now calibrated. I pull this out of my pH buffer 4 solution. What do I do with my pH probe? I rinse it off with my waste beaker, that's right. Someone said it, not everybody. And then I go to my pH 10 buffer beaker and I take my pH 10 buffer, I pour that. So this is review, right? We've done this way back at the beginning with skills. I put this down, I seal it again. Always make sure you guys seal your bottles, you don't want to knock them down and make a big mess. I drop this in to my buffer solution. I wait, 10, 15 seconds or whatnot. I scroll down to my next point here, which I already put at 10. I click Read from Sensor. Okay, so that's good. I click OK. I click OK, and I'm back to my experiment. So now my pH 4, my pH 10, I'm done with these. I'll pass them on to the next group. They'll use it. If I'm the last person, then I will bring it back to the teacher, and the teacher will pour it back into these bottles once they verified that you haven't contaminated it. So now, I'm working on an experiment. In my experiment, you'll also notice a PDF file on the website, and that PDF file will actually give you instructions on what to do step by step. It'll give you all the equipment that you're working with. We basically have something known as a reaction vessel. In the reaction vessel, that's where you're running the experiment. You're going to take about 50 mils, 25 to 50 mils of distilled water. So because it's so much, I'm actually going to open up my distilled water bottle. I don't want to place this on the counter because my counter might not be clean. So I'm going to get someone to hold this. Teresa, please. And then she's going to drip it on her bags or anything like that because then she'd be upset. I'm going to pour 50 mils of water in here. I don't have to be exact. Approximate is good. You want to be as precise as possible, but don't spend 5 minutes trying to get the perfect line here. But that's actually pretty good. Okay, so I'm going to pour this into my reaction vessel. 50 mils of distilled water. I'm going to seal my distilled water bottle. And now I need to add 1 gram. I'm going to work with 1 gram of antacid. So let's start with the simplest one, 500. Did someone take my 500 ml bottle? One of these? So I'm going to take my simplest one. This is the one that's probably the weakest, so it should be the quickest experiment to go. So I'm going to take them tablets out. I'm going to turn my scale on. I'm going to use my weigh boat to figure out what 1 gram is. Now, if I were just to measure a single tablet, I'm just going to put it right on the balance here, and you guys can't see this right now, it's telling me it's 1.2 grams. Okay? So if it's 1.2 grams, that's more than the 1 gram I want to work with. The reason why I want to use 1 gram is because it makes the math really easy. So I put it in my mortar and pestle. What's wrong with this? Is that the right way to use a mortar and pestle? No, I grind. So I use some pressure, and I grind until I get a fine powder. And as a reminder, are we supposed to wet this mortar and pestle? No, we're not. Exactly. So I'm actually going to do 2 tablets, because what happens when I grind it is that I end up with some of the tablet stuck to the sides, and I might not even be able to get a gram out, even though there's 1.2 grams in. So I've ground this to a fine powder. So when you look inside, you guys will see a nice fine powder. Then I take my weigh boat, and I'll have clean weigh boats for you. You'll get 1 weigh boat, and then you have to clean it with a paper towel. Put it on the scale. You zero out the scale by hitting the 0 button, or re-zero button. I'm going to put in 1 gram of powder. I have scupulas. Now remember with the mortar and pestle, you cannot put this on a bench like this because it might roll off and break. So you want to make sure you have some place to place it where it's not going to roll off the counter. So I'm going to put in 1 gram. 0.1, 0.2, 0.4, 0.6, 0.7, 0.9, 1. So I'm going to take this 1 gram of substance, and now I'm going to place this in my reaction vessel. Okay. Now you'll notice, this being a powder, the powder doesn't mix all that well. So I'm going to use a stirring stick, which I have cleaned thoroughly. You mix it up. You can actually see it's a little off color. It's not completely white, right? It looks like a little what? If you're closer, it'll kind of look a little lilac, kind of purple to you. Okay. So I have this dissolved in the water, for the most part. Now, I'm using a probe to get to the end point. I'm also going to use an indicator. Remember what an indicator does? It changes color at a specific pH. This indicator actually changes color at a pH of 2. So I'm going to place about 5 drops of this indicator called Thymal Blue. 1, 2, 3, 4, 5. And what it does is going to give me a color change. So as I keep on adding acid to this, it's actually going to start to change color. And then as I get a change in color on here, I know that I'm getting close to my end point. So I'm going to drop this in here. I'm going to run my experiment. Now, we don't want a graph. We care about a table. So I want a table of values. Now, in the instruction sets, I'm not going to go through it here, but in the instruction set, I tell you how to work with a table. Basically, you're going to have a couple of points in here. One of the points is going to be basically every single time you put in 20 drops of liquid. Can you pause that, please? So what I've done is I've actually given you the steps on how to do all that stuff I did on the computer online. Right? So basically what I care about is what's happening to my acid, right? So what I've done is I've actually done it the opposite way. I've added a base to this, and I'm going to add drops of acid. So you're also going to have at your station an acid beaker. So I'm going to come around. You're going to have glasses on, so you guys must be safe. Okay, don't litter. Remember, this acid is more concentrated than what you're used to, so you have to be careful with this one. You're going to want this one also labeled hydrochloric acid, and you're going to be adding basically a drop at a time. So I'm going to actually hit play. I'm not going to be on the play graph normally. Normally I'm not going to be on here. I'm just going to be on here so you can see what happens when I add the stuff. So right now I'm playing, and you can see my line moving across. So right now I'm at a pH of, looks like around 9 or so. So I'm going to add my acid to this, and at the same time, someone's going to be stirring. So Sean, I'd like you just to stir this. And I'm going to add a drop at a time. And then watch what happens to my little green triangle as I add it. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See what's happening to my green triangle there? See how it's moving down? So I added 15 drops. Now in your instructions, I've actually told you to add a certain number of drops and then keep the data. So the way I keep the data is by clicking this check mark, and then that's 15 drops, even though it's a time graph right now. And if I add 15 more drops, I'm going to keep on doing this until I get a pH of 2. Why do you think I chose a pH of 2? Based on the note I gave you about 40 minutes ago. 4, 5, 6, 7, 11, 12, 13, 14, 15. Pardon, Chad?
I didn't know. He said something about stomach acid normally being a pH of 2.
Good. So once we get a pH of 2, we know the whole thing is done, it's reacted appropriately. So I've added 15 more drops, and I'd hit keep again. Sean? Now what you'll find is some of the more powerful antacid, you need to add quite a few drops. Just so you know, this is a graduated pipette, and if I get to the 1 mil mark, that's about 20 to 25 drops depending on your fingers, right? So I know if I am in a rush, I know initially I can just add a whole mil, and I can call that 25 drops. It's not being a rush, but I just know it's going to take quite a few drops. So I've added 25 more. So I'm going to hit keep. And keep on going. So I'm still not at 2 yet. But what you'll find is you get a point where all of a sudden it just drops. So again, in the interest of time, see I added 25 more drops. See how it dropped, but it's coming back up because it's still reacting. So again, I'll do keep. I'm going to go over to my table view now. Right, so here I have a time. Here I have my pH values. They're going down. So I need to modify my table slightly to follow those instructions. I'm going to keep on going while stirring. So I'm at about 100 drops now. See how it dropped? Every time it drops like that, I know that it's getting closer and getting closer. And it's also going from a bluish tinge here to a red. And the moment I get that red tinge, something to hold a piece of paper on the bottom, I know I'm very close, and I probably want to go a drop at a time. I'm just going to drop in the full amount, just to let the experiment go a little bit faster. And realize I'm doing right now the normal strength. Each time I do one of these drops, 25 at a time, 25 at a time, 25 at a time, I should be hitting keep each time, so that way I have a graph of data that I can keep, depending on the kind of lab I'm working with. So I keep on doing this, and eventually I'm going to hit a point where it's going to stay below 2. When it stays below 2, that's when I stop my experiment. For those of you close, you can probably hear the bubbling, you can probably hear the reaction that's occurring. Let's do one more. So recognize each time I'm doing this, I'm adding 25 drops based on my count. And again, for those of you nice and close, you can probably see that's kind of pinkish. So stop stirring. So you see I'm below 2 now. I'm actually going to stop my experiment. And if I've done my table properly, I can go back to every single one of these, and I can change it from whatever is the default here is to 0 drops, 25 drops, 50 drops, 75 drops, 100 drops, 125 drops. I have my experiment. I figured out the normal strength antacid will take 175 drops, and I move on to the next one, and I might find that it takes 250 drops, and the next one, it might take 450 drops, and so on. So be aware, that's the kind of experiment you're running. That's basically your lab.